Hello, this is the lecture number 11 for the chapter sequence series, and today we'll discuss the special sequences. The first is 1 plus 2 plus 3 plus 4 up to n times. It is equal to n plus 1 upon 2. This we can easily prove that it is the sum of the first and natural number, and we write like this: summation of k, where k is from 1 to n. This and this means the same, which is equal to n plus 1 upon 2. So this is the first special sequence which is known as the sum of the n natural number. After that, it is sum of the squares of first n natural number, 2 square plus 3 square up to n square. It is equal to n plus 1, 2n plus 1 upon 6. In the short, we write like this: summation of k square from k to 1 to n, which is equal to n plus 1, 2n plus 1 upon 6. This is known as the sum of the squares of first n natural number. Will I give you some clue to obtain this formula? And the third is 1 cube plus 2 cube plus 3 cube up to n cube means sum of the cubes of first n natural numbers, which is n plus 1 upon 2 ka whole square. In the short, we can write this as summation. It is summation k cube, and the value of k is from 1 to n. This and this means the same, and this is equal to this. This is the sum of the cubes of first n natural numbers. I tried to prove this formula, and what you have to do in these type of questions, one more thing: if you add 1 n times, that is 1 plus 1 plus 1 up to n times, it will be n. Or you can write summation f 1 up to n will equal to n. Or if it is 2 plus 2 plus 2 up to n times, in this short it is written as summation 2 up to n, it is 2n, and so on. Now what you have to do in these types of question, if certain sequence is given, you can easily find the nth term of that sequence, and you add the nth term of this, and you will get the sum of all the terms of that particular special sequence. This is the method to do this type of question. Now let us try to find the formula, that is 1 square plus 2 square, which I have just discussed, which is equal to n plus 1 to n plus upon 6. That is, if Sn is equal to 1 square plus 2 square plus 3 square up to n square. Now we know that this identity, that x cube minus x minus 1 ka whole cube is equal to 3x square minus 3x plus 1. We know this identity. Now if you put the value of x as 1, then 2, then 3 up to n in this first statement, you will get 1 cube minus 0 cube is equal to 3 into 1 square minus 3 into 1 plus 1. Then when you put x is equal to 2, it will be 2 cube minus 1 cube is equal to 3 into 2 square minus 3 into 2 plus 1. Then when you put x is equal to 3, it will be 3 cube minus 2 cube is equal to 3 into 3 square minus 3 into 3 plus 1, and so on. The nth term will be, it will be n cube minus n minus 1 ka whole cube is equal to 3 into n square minus 3 into n plus 1. Now when you add all these terms, this will be cancelled out over this will be cancelled over this, and so on. So this will be equal to, this will cancel before this, so this will becomes out to be n cube, and when you add all this, you are getting this as 3, that is 1 square, 2 square, 3 square up to n square. It will be Sn, sum of the n Sn. This is, we have let it equal to this, and this comes out to be minus 3 into 1 plus 2 plus 3 up to n. and when you add this 1 up to n times, it will be n. Now when you replace this, find the value, replace this formula of n plus 1 upon 2, this is n. You can easily find the value of Sn as, that is n plus 1 and 2n plus 1 upon 6. This is the idea I've given to you. The proof is not so very important. And similarly, we can prove that the 1 cube plus 2 cube plus 3 cube up to n cube will be equal to the third formula we have done, that is n plus 1 upon 2 ka whole square. So this is the basics for the next exercise, that is exercise 9.4, in which you have to find the sum of the given sequences, which will be a special sequences. So first of all, I'll do the question number 8 and give an idea how you have to find the sum of the sequences. So it is given that you have to find the sum of n terms of the following whose nth term is given. आपको अगर किसी सीरीज का nth term given है, तो how you have to find the sum. Suppose this is the nth term is given, so what you have to do, you have to simply convert into this polynomial, that is n cube 5n square plus 4n. This is the nth term, and the sum, how you have to find it, sum will be, you can write summation of k cube, in place of n replace k, and you have to add it from 1 to n. Here also 5 summation of k square, and the value of k is from 1 to n, that is you have to add this term up to n times. This is nth term, this is s, and this is 4, in place of n write k, and from 1 to n, that is you have to add this 4n up to n times. And you know this formula, this is n plus 1 upon 2 ka whole square, this is 5n, n plus 1, 2n plus 1 upon 6, and this is 4n, n plus 1 upon 2. Now you can take n plus 1 upon 2 common in all the terms, and you can simplify as far as possible. So this is the basic concept to find the sum of the given sequence when the nth term is given, and the nth term is given, not given, you find the, try to find the nth term and then apply this step. Sn will be the summation of all the terms from 1 to n, because you have to find the sum of n terms of the given sequences. Let us take another, that is the question number 9. Again, it is given that the nth term is n square plus 2 ki power n. So if you find the sum, it will be summation of k square from k to 1 to n, and it is summation of 2 ki power k, where k is 1 to n. Now we know the formula for this, which is equal to n plus 1, 2n plus 1 upon 6. But this is not the formula for any, this is no formula for this summation of 2 ki power k. So you simply replace the value of k from 1 to n. So 2 plus 2 ki power 2 plus 2 ki power 3 up to 2 ki power n. And it is a GP up to n terms, which is equal to a r raised to power n minus 1 upon r minus 1, and this term will remain as it is. So this is the method to find the sum up to n terms and simplify as far as possible. So this is the method to find the sum when the nth term is given in the special sequences. And the last question of this, it is nth term is 2n minus 1 ka whole square. So first of all, you find the polynomial a square minus 2ab plus b square. So if you have to find the sum, it will be 4 summation of k square from 1 to n minus 4 summation of k from k1 to n minus summation of 1 up to n. So you know this formula, it is n plus 1 and 2n plus 1 upon 6, and this formula is n plus 1 upon 2, and if we add 1 to n times, I already told you it is equal to n, and simplify as far as possible. The general concept is if you know the nth term, you can find the sum of any sequence. This is the last 3 question of your exercise where the nth term is given. But from the starting question of this exercise, if it is 1, the 1 into 2 plus 2 into 3 plus 3 into 4 plus 4 into 5. You have to find the sum of this sequence. Now because 2 plus 6 plus 12 plus 20, if you take the terms as individually, they are not forming any AP or GP. So what you see it here, that is if you consider their first term, that is 1 2 3 4 and so on, they are forming a GP. And if we take the next terms, that is these, they are 2 3 4 5, they are individually forming the AP. So if you write like this, first term into 2 3 4 5 and so on, you find their nth term, which is an AP, that is A plus n minus 1 into D, and it is A plus n minus 1 into D. You simplifying simplifying the nth term, that is n, and this is, you will call it n plus 1. Yes ki nth term aa gayi. And when you know the nth term, I've just done the last three questions how to find the sum, that is Sn summation of k square, k की value from 1 to n. Similarly, summation of k की value 1 से n, like this. So it means you simply find, you know the formula for this, n plus 1 to n plus 1 upon 6 and n plus 1 upon 2. Simplify as far as possible. So what you have to do in these types of question, you simply find their nth term. So second is the 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 to 5 and so on. If you see it carefully, this is the first term of this, then we have this, and then we have this. So individually they are forming the AP. So it will be 1 2 3 and so on. Next will be 2 3 4 and so on. The next is 3 4 5 and so on. To find the nth term, it is A plus n minus 1 into D. The nth term is A plus n minus 1 into D. The next is A plus n minus 1 into D. The common difference in 1 in all the terms. So the nth term is coming out to be n plus 1, and it will be n plus 2. Multiply and open the bracket as usual. So it will be 3n plus 2, n cube, 3n square plus 2n. And as you have to find the sum, similarly you take summation of k cube, k की value 1 से लेकर n, 3 summation of k square, k की value 1 से लेकर n, 2 summation of k, k की value 1 से लेकर n. And you know the formula for this, n plus 1 upon 2 का whole square. You know the formula for this, n plus 1 2n plus 1 upon 6. And you know the formula for this also. This is n plus 1 upon 2 into 2. And simplify as far as possible. So this is the method to do these types of special sequences. You try to find its nth term and solve it. Question number 4. It is 1 upon 1 into 2 plus 1 upon 2 into 3 plus 1 upon 3 into 4 and so on. If you see it very carefully, you can do it by using the trick. For 1 upon 1 into 2, you can write 1 minus half. For this, you can add 1 upon 2 minus 1 upon 3. अगर आप इसको LCM लेके minus करेंगे, you will get this as. And for this, it will be 1 upon 3 minus 1 upon 4 and so on. If you go it with the last term will be 1 upon n minus 1 upon n plus 1. Because ये वाली term इससे एक ज़्यादा है, तो अगर ये n है तो ये n plus 1 होगा. If you see it, ये इससे कैंसिल हो जाएगा, ये इससे कैंसिल हो जाएगा, और ये वाली टर्म अपने पहली वाली टर्म से कैंसिल हो जाएगी. तो ये इसका सम आएगा 1 minus 1 upon n plus 1, that is 1 plus 1 minus 1 upon n plus 1. तो ये सम ही आ गया आपके पास. ठीक है, एलसीएम लेके माइनस करा, n it will be n upon n plus 1. So this is the question number 4. थोड़ा सा डिफरेंट था, आप इस तरह से कर सकते हैं. Now in question number 3, it is 3 into 1 square plus 5 into 2 square plus 3 into 7 square and so on. So if you see it carefully, this is the, it is third is 1 5 into 2 square, and it is next is 3 into 7 square. 1 into 3 into 1 square, then 5 into 2 square, then it will be 7, 3 into 1 square plus 5 into 2 square plus it will be 3 5 7 into 7 square होगा, तो ये आ रहा है like this. एक तो ये आ रहा है, एक 1 2 3 and so on, ये 3 स्क्वायर होगा यहाँ पर, ये स्क्वायर का टर्म है. तो इट मीन्स अगर आप इसकी nth टर्म पता करेंगे तो a प्लस एन माइनस 1 इंटू डी, कॉमन डिफरेंस यहाँ पर 2 है, और ये कितना है आपका ए पी है 1 2 3, तो nth टर्म विल बी n एंड इट विल बी स्क्वायर. तो इफ यू सॉल्व इट विल बी 2n प्लस 1 आएगा ब्रैकेट ओपन करने पर, और ये n स्क्वायर. सो ये इसकी nth टर्म हो गई. nth टर्म इज 2n क्यूब प्लस n स्क्वायर, और सम जैसे फाइंड करते हैं वैसे ही करेंगे आप. k क्यूब, k की वैल्यू 1 से लेकर n प्लस समेशन ऑफ k स्क्वायर, और k की वैल्यू 1 से लेकर n. इनका फॉर्मूला रखिए, सॉल्व करिए. दिस इज so like this you have to do this exercise, find the nth term and find the sum. That is, एक बार और लें, थोड़ा फिफ्थ थोड़ा बिल्कुल डिफरेंट है. इट इज़ 5 स्क्वायर प्लस 6 स्क्वायर प्लस 7 स्क्वायर अप टू 20 स्क्वायर आपको पता करना है. अब शुरू से ये नंबर नहीं है तो आप क्या लिख सकते हैं, 1 स्क्वायर प्लस 2 स्क्वायर प्लस 3 स्क्वायर अप टू 20 स्क्वायर. तो इसका मतलब हमने इसमें क्या ऐड कर लिया, 1 स्क्वायर प्लस 2 स्क्वायर प्लस 3 स्क्वायर प्लस 4 स्क्वायर ऐड कर लिया. तो इट मीन्स एडिंग एंड सब्ट्रैक्टिंग 1 स्क्वायर 2 स्क्वायर 3 स्क्वायर प्लस 4 स्क्वायर. तो ये शुरू के 20 नेचुरल नंबर का स्क्वायर का सम है. तो इसका फॉर्मूला होता है n प्लस 1 2n प्लस 1 अपॉन 6. इसमें nth टर्म निकालने की जरूरत नहीं है. सम ऑफ द स्क्वायर्स ऑफ फर्स्ट 4 एंड नेचुरल नंबर फर्स्ट 4, तो इट विल बी n प्लस 1 2n प्लस 1 अपॉन 6. तो ये थोड़ा डिफरेंट क्वेश्चन था. 5 स्क्वायर से लेकर 20 स्क्वायर तक का सम आपको निकालना था. तो व्हाट आई हैव डन, आई हैव एडेड 1 स्क्वायर 2 स्क्वायर 3 स्क्वायर प्लस 4 स्क्वायर एंड सब्ट्रैक्टिंग 1 स्क्वायर 2 स्क्वायर 3 स्क्वायर 4 स्क्वायर. दिस आर सम ऑफ द स्क्वायर्स ऑफ फर्स्ट 20 natural numbers, which is n plus 1 2n plus 1 upon 6, and this is the squares of first sum of the squares of first 4 natural number, which will equal to again n plus 1 2n plus 1 upon 6, where यहाँ पर n 4 है और यहाँ पर n 20 है. So 1 or 2 questions are remaining in this exercise, which can you try yourself by finding the nth term of the given sequence and find the summation after that. Okay, thank you. We'll discuss the miscellaneous exercise in the next lecture.